Here we go. The test, I usually have a test review ready for you, but I had a lot of changes I felt like I needed to make, so it'll be ready after school. It'll be a collection of topics on the test, but some sample problems. I want you to, considering I'm supposed to be preparing you for college, I need to get you moving away from do these problems as practice. That's Algebra 1 practice test stuff. You don't do that at college. You just don't very frequently get a practice test of problems. More common is they just say, here's what's on the test. They give you a bunch of common terms or ideas, and you have to know what they mean and can you do them. So I'll try and give you a blend. That said, the review will have some outline of what you're expected to know and some sample problems. I will say just basically this, it'll cover the summer review, which was meant to be a ton of pre-calculus practice. It'll cover limits, both finite and infinite. And all the various problems that go with that. It'll cover then continuity. You must definitely know the definition of continuity. It'll cover the intermediate value theorem. Make sure you know how to phrase that well. Basically, I want you to show betweenness and continuity and then say the intermediate value theorem guarantees, la 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 la. And then definitions of the derivative. Now that's all three. I know the alternate and the symmetric are a little new, so still debating whether you would do one or just recognize one, but to be safe, know all three, all right? The summer review packet, in terms of what you might definitely practice in case you're rusty, is first of all, do you know graphs and transformations? I know we just talked about that the other day, but it was also on the summer review, so it is old. Also, trig facts. Looking back, I don't usually tell you, hey, this is on the test. Hey, this is on the test. Last year, I had 10 just basic trig fact questions, and the average was something like a 6 out of 10. That's deplorable. I'm talking stuff like sine of pi over 3. You should be able to answer that within 10 seconds. Maybe 5 seconds. Maybe 2 seconds. What is it? Root 3 over 2. Okay. All right. Likewise, inverse trig facts, arc sine of whatever, 1/2. What is it? Pi over 6. What about arc sine of negative 1/2? Just to see if you know the ranges of these functions. Arc sine is from where to where? Negative pi over 2 to pi over 2. Negative 1/2 is there, so you answer negative pi over 6. Okay. All right. Those trig facts. If you feel like you're iffy on those, then I imagine there's websites. I should find one, but I'll also up the factors. I'll be here before school tomorrow if you have questions on the review, or just if you know you're weak somewhere and you come in and say, hey, can you give me a little extra practice on this or that, I'll be happy to do that. As far as a structured review, I don't have practice problems in the morning and say, hey, let me take you through these. I don't do it that way. I just am here at the very latest 7 o'clock, probably earlier. If you have things you feel weak on, just come in and you can practice whatever you want. Okay? In terms of test structure, I don't know how this compares to Mr. Slaughter's test, but I can assure you it's pretty much just like Ms. Candy's test if you've gone from Ms. Candy. It starts with, it's 2 pages. The first page is calculator. I have a couple calculators to borrow, but not a lot. Alan Lee, that turkey. If you see Alan Lee, tell him to give my calculator back. Page 1 is calculator. It should take roughly half the time, so budget about 25 minutes there. Page 2 is no calculator. I work that trade-off like the AP test. And it goes a little something like this. When you decide, all right, I'm good with page 1, you can do one of two things. You can either take it back and turn it in at that point and get the second page, and that's fine. You can keep page 1 if you think, I want to come back to that maybe if I have time. You can keep page 1 and go back and get page 2, but the minute you get page 2, your calculator goes away and you can never use it again, okay? I don't care if you turn in page 2 and say, hey, can I go back to page 1 and get my calculator? No, you cannot. The minute you pick up the second page, calculator's gone for the rest of the test. You cannot use it again. So if there's some problem, if there's a couple problems that you're still working on here and you want to get to the second page, I personally would just say, all right, I need to make sure I've done everything I need my calculator for, make sure that's done, and then go get the second page. And anything that's on that page that you don't need a calculator for, you can do that for later. Okay, is that clear? Any other questions generally about the tests? I will also say this, I'm a terrible test length judge. It depends on the class, but I can tell you, if you watch BC students take my test, they literally run from the previous class to this class, and they get here maybe 4 minutes before the class even starts to start the test. It's that long. I don't try and make A be that long. I will try and winnow it down a little bit more, so I don't expect yours will be too long, but do judge your time well. The pages are entered into the grade book separately. I'll have test 1, page 1 in the grade book, and test 1, page 2 in the grade book. They weigh the same thing. They will be the same point. So it doesn't help you to use 45 minutes to page 1 and then leave yourself only 5 minutes to page 2. That's no key. Yes?
Because we have a test tomorrow, is our problem set due Monday?
Good point. Yes, this homework that you just picked up is due Monday. Good question. Okay? Tuesday, right? Sorry. It's Tuesday. So wow, that's great. 4 days to do a problem set. Okay. Yeah. Those of you who come to Spanish class, I don't do homework for test days. You will not kill me. I don't do that. Okay? All right. Okay, so you have 3 papers, one of which is obviously the problem set. I have 2 sheets of notes I have to go through. I'm combining 2 sets on tonight's lesson, so I need to move. Here we go. It's a bit of a hodgepodge, or a potpourri, if you will, a collection of things. I love teaching here, and I love Saxon, but if there's one thing that Saxon is the worst at, it is graphic sinusoid. I am going to probably, for some of you, this is going to involve unlearning how Saxon taught you to do sinusoids. They make me want to throw up, okay? I will give you an example here. My big picture. If you graph y equals x plus 2 squared plus 3, what kind of graph is that? Parabola. Shifted how? Left 2, up 3, right? Tell me, if you're graphing that, would you first graph the parabola and then say, okay, here's -2, and this is 3, and is that what your graph looks like? No, that's crazy. You wouldn't graph the parabola first, then the axis. Furthermore, that's not even an axis, so that's crap. Do you agree?
Yes.
Great. Now, can you please tell me why some of you then, in graphing y equals 2 plus 3 sine of, let's just go x minus pi over 2, would say, okay, here's the wave, and here's 2, and here's 5, oops, that's badly done, and here's -1, and here's pi over 2. What? What? You don't graph this one, you don't graph the graph first, then the x is here. Why are you doing it there?
Furthermore, why are you putting the axis here? The axis isn't at 2. As far as I'm concerned, it's at 0. Always has been, always will be. So who do you think you are renaming the axis? You don't get to do that. Okay? So that is garbage. Garbage. All right? Instead, you will do it my way or the highway, baby. Are you ready? All right. It goes like this. First of all, you must be able to graph a sinusoid. You must first know how to find the period. To find the period, you should know that the normal period of sine or cosine is 2 pi. We will be working in radians, all right? The normal period for tangent or cotangent is, how long does it take to go through a full graph structure in tangent or cotangent? It only takes pi. Actually, the period for tangent and cotangent is pi. It only goes from negative pi over 2 to pi over 2, for example. And then it starts to repeat. Okay? The same would go for, if you talked secant and cosecant, those also are 2 pi normal period. Okay, so then, if you slap something onto the x, we know that that is going to change the x distance, or horizontally squish or stretch. So let's talk about it. Okay. 5x, does that stretch or squish? Stretch, good try. Try again. Stretch, still not right. Try again. Okay, there you go. Good job. Okay. It causes the whole thing to happen 5 times as fast. There are different ways of teaching this, but I basically say to find the period of a sinusoid, just take 2 pi, the normal, and divide it by whatever you see. So the period is 2 pi over 5, yeah? All righty then. We'll continue on in a second, but when you go to graph that then, I would expect you to not only have the full wave marked properly, but a half wave. If a full wave is 2 pi over 5, then a half wave is pi over 5, and I expect you to have the quarter points marked. So if a half is pi over 5, then a quarter wave is pi over 10. What do you reckon a good scale would be then for that wave? Pi over 10, because then you could find pi over 10, which you need to find. So you would choose your scale. You will choose your scale based on, that's a 10, not a 0, sorry. You'll choose your scale based on how long a quarter wave is, because that'll allow you to find all these points accurately. 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, everything's exact. With me? Okay, what's the period here? 2 pi divided by the coefficient, so 2 pi divided by v halves is 4 pi over 3, okay? What's a full wave? 4 pi over 3. What's a half wave? 2 pi over 3. What's a quarter wave? Pi over 3. So what scale would you use? Pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. You can find all points exactly, including going backwards. All right. Tangent of 3x. What's a normal period for tangent? Not 2 pi, but pi. Okay? So pi divided by 3 means the period is pi over 3. That case, then, a wave here would be pi over 3 wide and typically goes through the origin, yeah? Now, if this is a total of pi over 3, then how wide is it on each side? Half pi over 6, right? So it would go from negative pi over 6 to pi over 6. That's a total wavelength of pi over 3. We're good. So what scale would you use? Pi over 6. Now, when I say you use a scale of pi over 6, it's actually up to you whether you would, on your graph space, say, all right, is 1 box pi over 6 or 2 boxes pi over 6? That's up to you. You know, the little wider makes a little less graphing and a little less busy. So that's your call. But as long as I see a scale month. I should see a scale chosen in month. All right, what about this? What's the period? What do I do to find the period? Take the normal period 2 pi and divide by the coefficient 3 pi. So the period is 2/3. What does a positive cosine wave look like? Show me in the air. Okay. Yes, peak to peak, yeah? So if a total wave is 2/3, what's a half wave? A third. What's a quarter wave? 1/6. What scale do you use? 1/6. Okay. How about the last one? What's the period? 2 pi divided by pi over 2 is 4. Positive sine wave is center line up to all the way through to center line up again. If the period is 4, what's a half period? 2. What's a quarter period? 1. 1, 2, 3, 4. You just go by ones. Beautiful. Okay, you with me? Can you find the period?
Yes.
Can you find the quarter parts? Okay, here we go. Now then, I wish I had time to do this a little slower, but I'm just throwing you to the wolves, my friends. This is the process. It goes like this. Let's first do the vertical piece. What are the vertical pieces, which students usually do well? 3 represents the shift up. So you could think of it as the center line. It's the vertical shift. Okay? This is centered at -3. Now I don't have a or 3, excuse me. I don't have a problem if you use a dotted line there, just to keep your picture in line and remember where you're at. That's fine with me. Don't make it solid. Solid is for the graph itself and an axis and nothing else. So do not make that solid. What's the 4 represent? The amplitude. From the center line, we could either go up 4, putting us at 7, which I'm going to give myself a root, or down 4, putting me at -1. What's the range for this graph? -1 to 7 inclusive. Okay. Now then, here's where I pause and go to my, I think it was a rough draft. Okay. Cosine wave. What does it look like? Positive cosine. We just said peak to peak. Yeah. Let's go with the period. What's the period here? 2 pi over 2, which reduces to pi. I know the period is pi. What's a half wave? Pi over 2. What's a quarter wave? Pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi. Perfect. All right, now, it would be logical based on what I was getting at that the scale then would be pi over 4, right? Okay. Here's the bit of a gotcha, though. Pi over 4 is great, but I also need to do the shift. So I wish I wouldn't have had done this in 2 pieces. If it had been this, I would have used pi over 4. But to find the shift, I really need to be able to find pi over 6's also. So what goes through your head, to make a wave accurate, you want to choose the scale. First, look at the quarter period and the shift, and look for a commonality between them. What's common between pi over 4's and pi over 6's? Think common denominator. Pi over 12. All right, now, if you choose a scale of pi over 12, then everything is going to be beautiful. And you're going to find everything, all right? Now, in terms of me, I know this is more like preference, not right or wrong, just teacher preference. I don't like a lot of stuff shown here. Too busy, all right? I like you to tell me what the scale is once, and that's it, all right? I have your scale. I know what all the other points are. I'm good. This, does that shift at right or left, pi over 6? Right, okay. So this peak, which would normally be here, is going to shift right. Right, pi over 6. Well, where would that be in pi over 12? Pi over 6 would be 2 pi over 12. So wouldn't that be right there, 2 boxes over from the axis, yeah?
Yes.
Okay. Now, this is the great thing. Once you have a scale chosen, all of your other points can be pretty easily found. We know a quarter wave
Each new point is pi over 4 away from the previous one, yeah? All right, pi over 4 is how many pi over 12s? 3 pi over 12s. So each time I get a new point, I'm just going to go 3 pi over 12s over, or 3 boxes over. So from here, if I go 1, 2, 3 boxes over, I will be at the center line. If from there I go 1, 2, 3 boxes over, where will I be in the wave? At the bottom, the minimum. And if I go 1, 2, 3 boxes over, I'm a little off to the side, but where would I end up? Where would I be after that? Center line. Furthermore, you can go back. Here's this point here. I could also do boxes back. 1, 2, 3 boxes back, center line. 1, 2, 3 boxes back, minimum. 1, 2, 3 boxes back, center line. 1, 2, 3 boxes back, max. After that, smooth through, and boom. That graph is fridge-worthy. Am I right? That's the thing of beauty. As William Blake said, a thing of beauty is a joy forever, right? Do you guys read Blake in English? Surely you must. Okay. Is conic sections, we'll practice that, and I want those to be lovely, and they will. Is this the next thing in your notes right there?
Yes.
Okay, conic sections. Conic sections is the big old catch-all for if you take this two-cone thing and chop it a bunch of ways, you get a lot of different figures. If you chop it this way, you get a parabola. If you chop it this way, you get a circle. If you chop it this way, you get an ellipse. If you chop it this way, you get a hyperbola. Those are the kind of sections, and at this point you say, man, who cares? Why would you chop a bunch of cones? Okay? Well, from this idea comes a lot of actual real-lifey kind of things. Parabola, among a million other things, it represents projectile motion. Okay, so understanding parabolas, it's this not so much important, but that pretty important. All right, circles obviously that's important in a million different ways. Ellipses, especially for both on a nuclear level and a astronomical level, most things in an orbit due to gravity are pulled in an elliptical fashion, including the Earth's rotation around the sun. A hyperbola, if you have escape velocity astronomically, you could be slingshotted out in a hyperbola kind of fashion. So my point is there's a lot of applications to this. It, just like a lot of math ideas, it starts with some abstract who gives a rip and actually can be applied in a lot of ways, all right? That's how math often works. First create something and then figure out how to use it. Recognizing a conic section, you need to be able to look at what is said as a conic section and know which is which, all right? How do you, if one square is missing, normally you look at squares. You might have x squareds and y squareds, and they might have coefficients with them. If one of the squares is missing, then what do you got? Parabola, ellipse, circle, or hyperbola? Parabola. If one of the squares is missing, then you only have y equals x squared. This actually is cx. I should have given you general form. Okay. Depending on A, B, C, and D, mostly A and B, these could be different shapes. If one of the squares is missing, boom, parabola. That would be a sideways opening parabola. This would be a vertically opening parabola. Okay? One square is missing, parabola. If the squares have opposite signs, like this guy, x squared minus y squared, it's not a parabola because the squares are there. What is it? It's a hyperbola. Okay? The difference, all these have logic to them, by the way. The difference is set in stone. X can get big as long as y gets big with it. Okay, the difference must be 9, so if x gets big, y's got to also get big. With me? All right? If the same sign but different coefficients, So A and B are both the same sign, something like this, but they have different coefficients. What is that? That's an ellipse. Now that actually makes a good deal of sense because x squared plus y squared is a circle, but we know that multiplying by something stretches it. So this is a circle that's being stretched more in the x direction. So that just goes with what we know about transformations. Multiplying stretches a graph. Last but not least, same sign and coefficient is a circle. That obviously goes right to the Pythagorean theorem. If the distance is always the same, then you could get that distance in a lot of ways. That is a circle. All right, so tell me, actually on your own, look at each of those and tell me which kind of conic sections those are. You have 30 seconds. Go. Okay, first one. Circle, second. Hyperbola, third. Ellipse, fourth. Parabola, opening half. Sideways. This one. Parabola, and this guy. Hyperbola. If x squared is the lead coefficient of positive, then how's the hyperbola open? Sideways. And if y squared is positive, then it opens vertically. All right. Many of these graphs are not functions. I think if you remember your Algebra 1, remember functions pass the vertical line test. So that's definitely not a function, okay? Fails the vertical line test. For any one x, there should be only one y in a function. Because of that, this would be more of a relation, not a function. A relation is an equation relationship between two variables, but it doesn't have to be, though. For any one x, there's only one y kind of case. That's sorry. All right. In calculus, you often want to work with functions. So it'll be the case that you need to take this and split it and break it into two functions so that you can find the derivative at a point or find the volume when it's revolved or an area. You're going to want to rewrite this in two. So let's just say we look at this. Wouldn't you agree that that circle is not a function? Yes? If I solve this for y, then I'd get the square root of 4 minus x squared, but I would get plus or minus when I square root it, yeah? The positive would be the upper half, and the negative would be the lower half. Now, each of those individually, is that a function? Does that pass the vertical line test? Yeah. Does that guy by itself pass the vertical line test? Yeah. So by rewriting them into two pieces, they are now functions, and that opens a lot of doors for us later, you'll see. You need to recognize, then, graphs that are conic sections rewritten in function notation. This guy, for example. If I wanted to sketch this, I might be tempted to think, well, square root, it looks like that. Well, no. Not every square root looks like that. It kind of depends on what's in the square root. Instead, you say, well, let me write this as y and see what happens if I clean this up. I could square both sides, and eventually I would get something like y squared plus x squared equals 36, right? So what's that graph? A circle with a radius, a center at the origin and the radius of 6. Is it the full circle? Okay, this is the full circle, but the original graph was just the positive y. So is it the full circle? No, semicircle. Okay, just the positive y. So that's the idea. play around with the equation a little by putting it in a more familiar form. Usually this will involve squaring, and then sketch the graph. Try that on your own, and we'll talk about those. Let's ¿Listos? See? Okay. The second one. I square both sides, move stuff over, looks familiar. What kind of graph is it? Two squares, different sides. It's a hyperbola, opening sideways or vertically. Sideways or vertically. Vertically, y squared minus x squared is vertically. When x is 0, y is 6. That's the vertex is 0, 6. Both parts or just part of the graph? Well, y at the beginning was only positive, so I can never get a negative y. This graph, this part of the graph, couldn't happen. It's just the top. Is that a function? Yeah. Okay. The next one, if I square both sides, I get what looks like two squares, same sign, but different coefficients, which feels like ellipse. I took the next step of putting it in standard form. It's centered at 0, 0, but it's stretched, or what's the horizontal change from side to side? 2 sideways, and how much vertically? 6. I didn't space that well. 6. Normally I'd say then that kind of ellipse, but looking back at the original equation, was that both parts of the function or just part? Just part, just the bottom. Negative y's only, so I'm only down there. That graph would only be down there. We'll get to it. Okay, this guy, cleaned up, looks like this. What is that graph? Hyperbole, yeah? Sideways or vertically? Sideways. This is going to kook you out. Okay, sideways. Top half, bottom half, right half, left half. I have positive y's only. So positive y's only are these two guys, yeah? Let's pause and do some calculus. How does this hyperbola behave as x goes to infinity? Or what's the end behavior? What does it behave like? It starts to behave, I know it looks like parabolas, but it's really more linear. Hyperbolas follow asymptotes, yeah? Okay, so first of all, if you look at a hyperbola from space, it doesn't look like two u's. A hyperbola from space looks like two lines. All right.
Sure, when I zoom in here, yeah, I got some curvy action. But when you zoom out, they behave linearly. They approach linear. Now, think of limits here. End behavior. As x gets infinitely large, this starts to mean less and less. Subtracting 25 from a trillion means nothing. And it starts to behave just like the square root of x squared, which is x. It starts to behave like a 1. All right? Back to this guy. X squared plus y squared is 9 is a circle. Which half? Top half or bottom half? Bottom half, radius 3, center to 4. Cool? Cool. All right, moving along. Putting a conic into your calculator. This goes to whether you have the Fancy Pants Inspire or Ghetto Calculator 84. I prefer the Ghetto Calculator myself, but the Inspire, in this case, has it all over it. So, this is the thing I would like you to do. We're going to put that equation in there. Now, if you go to your graph, if you go to your graph, okay, if you go to your graph, default is function mode, right? Okay, we don't want function mode because if I want function mode, then I would have to solve this for y, and that involves completing the square, and that's yuck. We're going to have to do that in a minute, but right now, if we can avoid it, we will. If you go to your menu and instead go to graph entry edit, which is really graph type, and you're going to go, you could go to equation templates. If this were in standard form, I probably would, but here I think you'll want to go to relation. You want a relation between x and y. Now just type in the equation exactly as you see it. Okay, it's menu, graph entry, relation. Okay, now if you don't have that, it's because your Inspire's not updated. Sucks for you. We're going to have to update your Inspire because, man, that's beautiful. So you don't, how many of you don't have that relation? Oh, man. Stinks for you. Stick with me because I will update it, but check out, so pause just a second. If you don't have that updated, you just type it in the way you see it. X squared minus y squared plus 2x. What do we got there? Minus 4y minus 9 equals is over here. 0. Boom. Hyperbole. Okay? The other line. If you go to put in this guy, it would be more like y equals x plus 3, which we know is a line. There you go. All right, now, stick with me. We'll go back to people who don't have it updated, and we'll work it out. This, I want to, when I solve a system, what am I looking for? The intersection, all right? So if I go to find the intersection in this, I'm going to go to Menu, Analyze Graph, Intersection. It looks a little different when you're in relation mode. It asks you to draw a box around the point you're finding. So when they say first corner, I'm going to say here. Second corner, then you're going to, oops, darn it. Second corner, I'm not used to doing this on the smartboard. I'm going to go across and make a box that encloses that intersection point. Boom, there's the intersection point, negative 3.75, negative 0.75, okay? If you don't have this updated, then do you have equation templates? Do have that. Okay, in that case, then you could go to equation templates general. I should have crossed this out on it. And go there. I need to start from scratch. You don't have that one either? Okay, that then is going to be a whole nother problem. We'll get to it. But graph, equation templates, conic, if it's not in general form, or if it's in general form. So it's 1x squared, negative 1 y, how many xy's do we have? My bad. Oh my gosh, I can't believe it does this for you. That's terrible. 0 xy's. That's the worst. I spent months mastering that XY term, and you guys could have just do it with no effort whatsoever. That's terrible. Y squared is -1. You hopefully are seeing the idea. What is, oh, what the heck? Why is that so highlighted? What's going on? Okay. Where are we at here? The x's, 2, the y's, -4, -4, not -4. Holy cow, this is long. -9. Does it equal 0? Boom. Yay, same graph. Okay. Now, I don't know if it'll let you go back to function mode. I think once you're in this mode, you have to stay in that mode, yeah? Is that true? Can you go back to function mode, or you have to stay here? So if you go to input the next graph, this here would have to be put in general form, everything on one side. So that's more like x minus y plus 3 equals 0. So you would have to put all those in as no x squareds. No y squareds. Come on, baby. No xy's. 1x. -1y. Plus 3. Did you get it?
Yes.
Okay, now practice finding the intersection point. Intersection point is menu, analyze graph, intersection. You're going to draw a box around it, so move around till you're above and hit yep, maybe something like that, and then move. This is not going well. Down until you're at the opposite corner, hit enter, and get it. Now, okay. For the most part, people are good. Maybe problems here and there. Let me go back and talk about problems then. If you have an updated Inspire, you should have a relation button. If you don't, then you'll use the general conic. Sometimes, however, you're going to have to go get a calculator and actually solve for y. So one more thing, and then we're good. X equals y squared is not a function. Why isn't it a function? Because it fails the vertical line test. Fails vertical line test. Or in other words, for any one x, there are 2 y's. That's not okay. Could you split it into 2 pieces? So it is a function? Yes. This would have to be y equals square root of x, or when you square root, it's plus or minus. So square root of x is the top half. Negative square root of x is the bottom half. Okay, when you want to make this a function, you have to go plus or minus when you square root. Now, the problem then is sometimes you're going to have to do that. Oh yeah, yeah. X squared minus y squared plus 2x, so you have it in front of you. X squared minus y squared plus 2x, what was the next part? Minus 4y? Minus 4y minus 9? Equals 0. Okay. Sometimes you're going to be asked to take this conic section and write it as 2 separate functions. You must, therefore, solve for y positive and y negative, the top half and the bottom half of this graph. In this case, it's a hyperbole, okay? It's going to involve completing the square. So let's start by getting the y's on one side. If I move the y's over here, then I have something like y squared plus 4y on the right, and on the left I still have x squared plus 2x minus 9. We? Okay, fight the temptation to factor out a y, which doesn't help you. Instead, complete the square. That's how we're going to get that square root for the plus or minus. What goes here to complete the square? What? I heard somebody say it. 4. Half of this coefficient is 2. Squared is 4.
Balance the equation. If I add 4 there, I must add 4 to the other side. If you did your job, then you must have completed the perfect square. It should be a perfect square of y plus 2. On this side, I could do stuff over there, but I don't really care what x does. I just want y. So now, solving for y, what would you do? Square root, and when you square root x, it's plus or minus. So y plus 2 is plus or minus the square root of x squared plus 2x minus 5. Wait. Last but not least, finish. And write as two functions. One function is negative 2 plus root x squared plus 2x minus 5. The other function is negative 2 minus x squared plus 2x minus 5. Make sure that 2 is negative in both cases. It's a negative 2 over there. Plus or minus is only in front of you. Okay? If you were to graph that, you would find that top one is the top half of the hyperbola, the other one is the bottom half of the hyperbola. That would allow you to put them into your calculator. If you had an 84, you'd have to do all that to get it into function. All right. So, 2 minutes for the power rule. Probably not. I'll finish it here. So now that just leaves me with 2 minutes for questions on 2 problem sets. Hit me. Hourly, effort, and okay. Questions, anything I could put up or give you a little help on? Throw something out there. Set 20, 21, 20, or 21 this, or 22 that. All of them out. Okay, before they start with the announcements, I'm just going to say this, I guess. Get all in place. I want these 2 homeworks by the end of the day tomorrow so I can grade them for the weekend. So whenever you come in, when I say those 2 homeworks, first of all, I mean 2021 and 2122. The previous homeworks, they are due at the end of the day, Friday. Are you with me?
Yes.
Okay, that gives you 7th hour today if you need a pass, after school today, before school tomorrow, tomorrow 7th period, whatever you do tomorrow. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I'll be around if you have questions. I'll come to your desk separately.
Stay for 7th hour. Students report to the 5th hour class.
Yep. Yeah. Are you coming from the same class as you? Okay.
For new heroes tonight.
Yeah, that's right.
Friday, 7. All 14 heroes are welcome as we head out for contact skills and javelin, discus, and shot. Sign up with
Tomorrow? Are you related to?
Oh no, that is good song.
That's it?
No, that's not right. I'm just not related to it.
Oh, okay. Okay. 8:30. There you go. Hi.
I can't solve it. It's so fast.
Hey, sorry, that's why, that's all the more reason you have to do it. Because of declarations, which means you're gonna want to do the words. So, yeah, you're gonna have to solve.
Don't forget, share your book forms on your signature dates in the library by
As two separate functions.
Will they be able to like the state requires that you can't take
Yeah, yours will do that.
yeah, I know that, but we're on the side.
to enroll as mentors for the first time.
This I think is the only place where you use it. There are a lot of places where you use it. I think about that a long ago. I think this is the main issue. Calc 2 is a slightly different issue, but that's not probably calculus. Hi. Yes. Hey, if you off the phase due tomorrow, if you're going to do that, be off the phase. I do.
It's all free, guys. Take home practice. Good luck at Jaguars are always greener. I don't coming through. That's right. Senior high students are homecoming is coming up fast.
Boom. There's the notes. Notes are optional. I recorded the lesson, so if it helps you guys find it's got this is. This is.
I have that.
Oh, okay.
Yeah.
That's the only one.
Yes.
Have a good day.